Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is a pure Mathematics 3 for October-November 2022, and the code is 9709/32. Let's move on to question number 1. Question number 1, find the value of x for which this equation, give your answer in the form of ln A over ln B, where A and B are integers. So first of all, I will copy the question. Now to get the answer in terms of in ln form, so I will take ln both sides. Now we have a formula, ln A plus ln B equals to ln A times B. And at the same time, ln A to the power of B is B ln A. So since for the left hand side I have ln of multiplication of two terms, then I will be referring to the first formula, which means it will be ln 3 plus ln 2 to the power of 1 minus x equals to ln 7 to the power of x. Alright, then the next step is going to use the second formula. When you have any power here, you can just bring it down. Then I will be getting ln 3 plus 1 minus x multiplied with ln 2 equals to x ln 7. Then after that, I will just do expansion. So ln 3 plus 1 times ln 2 is ln 2. X times ln 2 is minus x ln 2. Then equals to x ln 7. So to get the x, this whole term will be moved to the right side. Then I will get ln 3 plus ln 2 equals to x ln 7 plus x ln 2. So for the right hand side, the x can be factorized out. Then you get ln 7 plus ln 2. Then from here, my x will be ln 3 plus ln 2. Ln 3 plus ln 2 is basically ln 6. Then divided by ln 7 plus ln 2 is ln 14. So that's the solution for this question. Now, question 2. Solve the inequality where a is a positive integer. So now modulus of 3x minus a greater than 2 times modulus of x plus 2a. So the definition of the modulus is square root, right? Square root of the squared. This is the definition of modulus. Then now to eliminate or to simplify this, I will square both sides. So when I square both sides, the square and square root will be cancelled off for the left hand side. Then I will get 3x minus a squared. But then for right hand side, you need to be careful because this square you bring into both, to 2 and also to the square root. So when you bring the square to the 2, it becomes 4. And then you bring the square to the square root, then the square and square root will be cancelled off. Then again, I will get a quadratic. Alright, so now you need to expand this using quadratic formula. A plus b squared, it will be a squared plus 2ab plus b squared. Then now, when I do expansion, square of 3x minus a is basically 9x squared minus 6xa plus a squared. So for the right hand side, when you square the x plus 2a, it will be x squared plus 4ax plus 4a squared. Then now you expand this 4, bring into the brackets, then it will be 4x squared plus 16ax plus 16a squared. So now I will rewrite the left hand side, and then now I will bring all the terms on the right side to the left side. So when I bring all the terms, I'll get 9x squared minus 6xa plus a squared minus 4a squared minus 16ax minus 16a squared more than 0. Then from here, when you simplify, 9x squared minus 4a squared, I will be getting 5x squared. Then minus 6ax or xa minus 16ax, it will be minus 22ax. Lastly, okay, a squared minus 16a squared, it will be negative 15a squared greater than 0. Then now you can factorize this quadratic into two linear factors, 5x minus 5a and 5x plus 3a greater than 0. So for the first brackets, when you let it be 0, your x is 5a. For the second brackets, when you let it be 0, right, it will be x equals to negative 3a over 5. Means that now, when I sketch this graph, okay, obviously when you sketch this quadratic curve, you'll be getting a minimum point. Therefore, the graph will be U-shaped. This is the x. Then here is going to be negative 3a over 5, and this is going to be 5a. So now the graph, this whole graph is greater than 0, means it is above the x-axis. Okay, which means your x is either less than negative 3a over 5 or x is greater than 5a. So that's the solution of this question. Now for question number 3. Given the complex numbers u is a plus ib, w is c plus id, where a, b, c, d are real, prove that the u plus w star here, that means this is the conjugate, okay, equals to conjugate u plus conjugate w. So now what to do is I will just count u plus w first. So it will be a plus ib plus c plus id. Okay, then here is going to be a plus c plus I, b plus d, which means your a plus c is the real part, b plus d is the imaginary part. So the u plus the conjugate of this term, of this summation, is going to be a plus c minus I of b plus d. Okay, now we're going to prove this equal sign. So now, from here, I would say that it is same as a plus c minus bi minus minus di. Then now I will group the a and b together. So it will be a minus bi plus c minus di. So when you compare a plus bi and a minus bi and a plus bi or a plus ib, the difference is the imaginary part. From minus change to plus. That means the first one is a conjugate of the u, and the next one, c minus di and c plus di, that is the conjugate of the w. Okay, so with this I have proven the formula. Now b, solve the equation. Okay, again this is a conjugate of z plus 2 plus I, then plus z times 2 plus I equals to 0, and give the answer in x plus iy. So now I will write here. See, for this we can just use the formula from previous. Okay, so that means z is z here, 2 plus I, 2 plus I. So I let z be the u, then 2 plus I be the w. That means this is u plus w conjugate, right? So this is the u, this is the u, then this is a conjugate. Then I can split it into u conjugate plus w conjugate, right? So now I will copy the question. So let z be u, w be 2 plus I. Okay, let u be z. That means z plus 2 plus I conjugate equals to u plus w conjugate. So it will be u conjugate plus w conjugate. That means this is going to be z conjugate plus 2 minus I. Okay, so I'm going to substitute this result into the equation. So now it will be z conjugate. So let's say this is the first equation. So from first plus 2 minus I get this from the first term. Then plus 2 plus I, z equals to 0. Okay, and then I will let my z be x plus iy, because you need to leave your answer in x plus iy. Right, so the conjugate of z, so from here, conjugate of z is going to be x minus iy. So I will replace x minus iy plus 2 minus I plus 2 plus I multiplied with 2 plus iy equals to 0. So here I need to find the x and y. Alright, so now what to do is just group together. So x plus 2, then minus I, y plus 1. Then for the second term, you need to do expansion. So when I do expansion, I will get 2x plus 2yi plus xi plus yi squared. So for your information, I squared is minus 1. This is minus 1. Okay, this is minus 1. So now I will group the real and imaginary parts. So x plus 2. Now from the second term or second bracket, I will say third bracket, I will have 2x and minus y, because here is minus 1. This will be my real part. So I will plus 2x minus y. Okay, then minus I copy this, y plus 1. So when you look at here, this is 2yi, xi. Both are plus, but I have factorized minus. Means that I will be getting minus 2y minus x. That equals to 0. Right? So from here, I simplify. So x plus 2x will be 3x plus 2 minus y, real part, minus I. Now again, when you simplify this, y minus 2y is minus y. Then plus 1 minus x equals to, right hand side is 0, I will write 0 plus 0i. Then now I will compare. So my real part, 3x plus 2 minus y equals to 0. That means my y is going to be 3x plus 2. I'll let this be first equation. Oh no, just now I already used first equation, so now I let this be second equation. And then when I compare the imaginary part, minus y plus 1 minus x is 0. Okay, so I let this be second equation. No, sorry, third equation. So now I substitute second into third equation. So my y will be replaced by 3x plus 2. So negative of 3x plus 2, then plus 1 minus x equals to 0. Then when you bring in the minus, you will be getting negative 3x minus 2 plus 1 minus x equals to 0. Okay, so minus 3x minus 1x minus 4x. This minus 2 plus 1 is minus 1 equals to 0, which means 4x is negative 1. Therefore, your x is negative 1 over 4. So once you find the x, you can just find the y, either from second or third equation. So I get it from second equation. So my y is going to be 3 times negative 1 over 4 plus 2. So you get negative 3 over 4 plus 2, it will be 5 over 4. Okay, so then my final answer, the z is, because just now I let my z be x plus yi. So now just combine. The x will be negative 1 over 4, the y is 5 over 4. So plus 5 over 4i. That's the solution of this question. Okay, question number 4. Express this in partial fractions. Now, first of all, look at the degree of the x, the highest degree. Numerator is degree 2, denominator when you expand is also degree 2. That means you are given an improper rational function, which means first step is to use the long division, or what we call as polynomial division, before the partial fractions. So for polynomial division, I need to expand the denominator. Then I will be getting 2x squared. So 2x times minus 3 is minus 6x. Then minus 1 times x is minus x. Then plus 3. That means this is going to be 4x squared minus 13x plus 13 over 2x squared minus 7 plus 3. So now I will divide first before the partial fractions. So 4x squared minus 13x plus 13 divided by 2x squared minus 7x plus 3. So we need to times 2 to 2x squared in order to get 4x squared. So 2 times minus 7x becomes minus 14x. 2 times 3 is 6. Then now you minus. First term when you minus, you get 0. Second term, minus 13x minus 14x is plus 1x. So 13 minus 6 is plus 7. Okay, once you get the degree of the remainder of x is less than the degree of the x in the divisor, that means you can stop performing this polynomial division, which means this is basically same as 2 plus x plus 7 divided by these two linear factors. So now my partial fractions will based on this latest form. Okay, so now I will start finding my partial fractions. Now once you have performed the polynomial division, it will reduce it to proper rational function, which means now the numerator with x degree 1, denominator with higher degree. Then now, since the denominator has two linear factors, then I will write over first linear factor plus over second linear factor. And both numerators will be constants. Okay, so now the next step is to get the same denominator as in the left hand side. So now I need to times first term with x minus 3, then divide by x minus 3 because I have 2x minus 1. And same goes to the next term. It's going to be multiplied with 2x minus 1 because I already have x minus 3. So I times 2x minus 1, then divided by 2x minus 1. Okay, so now I will cancel off all the denominators because they are the same from left and right side. And I will just consider the the numerators. Then I will be getting x plus 7 equals to a multiplied with x minus 3 plus b multiplied with 2x minus 1. Now, to find the a and b, okay, you can substitute x, any values for x, but the easiest way is just let the factor be 0. So I will let x minus 3 be 0. So when x minus 3 be 0, that means my x is going to be 3. So now I have to substitute 3 into this whole equation, including the left hand side. So now 3 plus 7 is going to be 10. Okay, let me show you step by step. Then for the first term, whenever you see x minus 3, it will be 0. That means no need to count the a. I mean, you can't find the a because a times 0. Then you will be getting the b. So 2 times 3 minus 1. So from here, you will get 10 equals to 5b. Therefore, your b is 2. Now, for the next one, I'm going to let the second factor be 0. 2x minus 1 be 0. So now, when 2x minus 1 be 0, that means the x is going to be half. So for the left-hand side, half plus 7 equals to a bracket half minus 3. So half plus 7, you will get 15 over 2. Then half minus 3 is negative 5 over 2a, which means now my a is going to be negative 3. Okay, So I will rewrite the a and b in these partial fractions. So x plus 7 over 2x minus 1 times x minus 3 is going to be negative 3 over 2x minus 7 because of the a here, plus b over x minus 3 from here. Okay, so 2 over x minus 3. But this is not the final answer. Our final answer is together with the 2. Alright, so I will rewrite the question. It will be 4x squared minus 13x plus 13 over 2x minus 1 times x minus 3 is 2 plus, okay, 2 plus these partial fractions. So it means that I have to add on 2 to these two terms. So it will be 2 minus 3 over 2x minus 1 plus 2 over x minus 3. So that's the solution of this question. So every time before you get the partial fractions, make sure you have checked the rational function is proper rational functions. Otherwise, you have to perform polynomial division first before the partial fractions. Okay, so now question number 5. A. On a sketch of an Argand diagram, shade the region whose points represent complex number z satisfying the inequality modulus z minus 3 minus 2i less equals to 1 and imaginary of z greater equals to 2. So for the first one, it's going to be z minus 3 plus 2i less equals to 1. This is basically a circle. Okay, this is a circle with center 3, 2, and then radius is 1. Okay, 1 because of here. Then imaginary z greater equals to y, greater equals to 2. So it will be imaginary x plus iy greater equals to 2. Imaginary part is 2. Is y, sorry. Imaginary part is y. Therefore, you are sketching y at least 2. Okay, so from here, we need to draw the Argand diagram. Let's say this is imaginary and this is the real part or real axis. Okay, now I will draw the circle first. 3, 2. Let's say here 1, 2, 3, 1, 2. Okay, so 3, 2 is here. Radius is 1, so it will be touching at 4. Go up 1, go down 1, then go to the left side 1. That means here is 3. Okay, so now draw a smooth circle. Maybe it's not accurate because here is quite white. So please use the same scale, okay? This is 3. And then here the 4. 4 is going to be right. So okay, let's say I sketch this. Now okay, let's say this is your circle. It's not very accurate. Okay, let me just ignore all this. Then it will be easier for me to label. Alright. Or you can just draw using, you can just measure using the the ruler for the x-axis, for the x and the real imaginary parts. Then from here I know that this is 3. Okay, 3, here is 3, then 2, this is 1. That means it's roughly, okay, this is image, this is real part. Then here is going to be 4. This is 3. Here is going to be 2. This is going to be 1. So it means here is 1. Here is 0. I just simply sketch, right? That means this is 2. Here is going to be 3. This is 1. Okay, so now this is the circle. And then we have another one which is y at least 2. So y at least 2 is here. This is y equals to 2. Okay, at least 2 means above, right? So this is less equals to 1 means all inside the region, which means your region is here. This is modulus z minus 3 plus 2i equals to 1. Okay, so that's the region for this part. Now B, find the greatest value of argument z for the points in the shaded region, giving your answer in degrees. So now, argument z, greatest argument z, okay. Argument is the angle, right? So means that it will be, when you measure, it will be something here, roughly here. This is the greatest. So please draw using ruler. Okay, this is wrong. Okay, now for the greatest argument, you just check which point will give you the greatest angle. So for my graph here, it should be something like something here, okay, somewhere here. Alright, so that is the greatest. Then now how do we find this? So here will be touching, that means here is 90 degrees. Alright, then now I can split it into 2, because I know that this point is 3, 2. Then when 3, 2, then I can find the angle. My angle is, let's say, here theta 1, here theta 2. So my argument is basically theta 1 plus theta 2. Okay, so now I will write here my greatest argument of z is theta 1 plus theta 2. Okay, so when I draw the diagram, so now I will redraw the diagram here. This is 90 degrees, then this is 2, this is 3. Okay, because here is 3, here is 2, right? Here is 2. Okay, so now I need to find, this is my theta 1, this is my theta 2. Okay, so then I know that this is radius, here is radius. That means here is 1. Okay, so means here is 1. Now, I need to know what is this side. So, since here is 90 degrees, this side can be found by Pythagoras theorem. Okay, so let's say this is square root of, so this diagram is my working, right? This is square root of 2 squared plus 3 squared, which is square root of 13. Okay, now for the theta 1, because I know that the center is with coordinates 3, 2. So now I have opposite side 2, adjacent side 3. That means I will get my theta 1, tangent theta 1. Probably you can just write tangent theta 1 is 2 over 3, which means theta 1 is inverse tangent of 2 over 3. So later I will count what is the value. Okay, so now for the theta 2, since I know the opposite side is 1, and this is going to be my adjacent side, square root 13. So it means that opposite and hypotenuse. So opposite and hypotenuse is going to be sine. So sine theta 2. It will be 1 over square root 13, which means my theta 2 is going to be inverse sine 1 over square root 13. Therefore, my greatest argument for the complex number, okay, which is theta 1 plus theta 2. So I will get inverse tangent 2 over 3 plus inverse sine 1 over square root 13. And now you need to leave your answer in degrees. So when you get the total of these two values, it will be 49.8 degrees. Okay, so this is how I get it from the Argand diagram. Now, question number 6. Using the expansion of sine 3x plus 2x and sine 3x minus 2x, show this. So now, we have sine 5x. Sine 5x is same as sine 3x plus 2x. This sine x is same as sine 3x minus 2x. Alright, so I will write down the expansion first. Sine 3x plus 2x is basically sine 5x. We have a formula. Okay, refer to this formula. Sine A plus B. It will be sine A cos B plus plus cos A sine B. When it is minus, then here minus. Okay, so now I'm going to apply this addition formula. It will be sine 5x cos 2x. Then plus cos 5x sine 2x. Then for the sine 3x minus 2x, this is basically sine 5x. 5x. This is sine x. Right? It will be sine 3x cos 2x minus cos 3x. Okay, I think I made a mistake. This is not 5. It's 3. This is sine 3x, then cos 3x. Then here is going to be sine 2x. Now, I need to prove this. So I will start with half of sine 5x plus sine x. It's going to be half of, copy down these two expressions. So sine 3x cos 2x plus cos 3x sine 2x. This is for sine 5x. Then I plus with sine 1x. So it will be sine 3x cos 2x minus cos 3x sine 2x. Okay, then now I simplify. So sine 3x cos 2x, sine 3x cos 2x. Alright, it will be double. But then when you look at the next one, this is plus, here is minus. That means it will be cancelled off. Okay, so I will be getting half times 2 sine 3x cos 2x. So the half and 2 can cancel off. It becomes sine 3x cos 2x. So that's all for this question. Alright, so 6A is done. Now B, hence means use a previous answer, show this integration. So now, integration from 0 to 1 over 4 pi sine 3x cos 2x dx. So sine 3x cos 2x from the previous expression, sine 3x cos 2x is basically half of sine 5x plus sine x. Okay, So now I will change this to half of integration 0 to 1 over 4 pi sine 5x plus sine 1x dx. I get it from the previous part. Then now we can easily integrate this. When you integrate sine 5x, it will be negative cos 5x, then divided by 5. Because when you differentiate 5x is 5. And again, when you differentiate plus sine x, it will be negative cos x. Limits from 0 to 1 over 4 pi. And then now, just need to replace the x by 1 over 4 pi first. So I'll get negative 1 over 5. I take out the over 5. Then cos 5 times 1 over 4 pi is going to be 5 over 4 pi. Then minus cos x is pi over 4. Then you minus when the x is 0. So remember, cos 0 is not 0. Cos 0 is 1. So you cannot ignore it. Therefore, minus 1 over 5 cos 0, then minus cos 0. Okay, then from here I will get half negative 1 over 5 cos 5 over 4 pi is going to be square root 2 negative square root 2 over 2. Okay, minus cos 1 over 4 pi is positive square root 2 over 2. Then minus minus is a plus. Cos 0 is 1. This is 1. This is 1. Therefore, I will get, right, so plus 1 over 5, then plus 1. Then from here, I will get half of, this is square root 2 over 10 minus square root 2 over 2. 1 over 5 plus 1 is 6 over 5. And now we need to prove this. Okay, so we should have over 5. So what to do is, you make it to the same denominator first. So half over 10, which means I'm getting root 2. And then for the second term, I need to times 5 and over 5. So when I times 5, I will get 5 square root 2. Then here plus 6 over 5. Okay, and now bring in the 2. So bring in the half. I will say it is the numerator 1 square root 2 minus 5 square root 2. I will get negative 4 square root 2. Then over 20. Then plus 6 over 5. And then now the 4 over 20 is basically negative square root 2 over 5 plus 6 over 5. Then from here I can factorize the 1 over 5. And now just check the final answer. You need 3 minus root 2. So, okay, wait, I forgot one term here. This half I times into the first term. I forgot to times to the second term. So when I times to the second term, here should be over 10. Okay, so when over 10, then I can sorry. So when over 10, this is going to be 3 and 5. Then I will get 3 over 5. Okay, and now when you look at the answer, I need 3 minus square root 2. So I just rewrite the position. It will be 3 minus square root 2. So shown. So this is how we show the integration. Alright, so now next question, number 7. The variables x and y satisfy the differential equation where y equals to 1, x equals to 0. Solve the differential equation obtaining y in terms of x. So now e2x dy over dx is 4xy squared. Now I move the y to the right side and move all the x to the other side. Then I will get y to the power of negative 2 dy equals to 4x. The e2x when you move to the other side becomes dy. So when dy I move up, it will be negative degree. Then move the dx as well, and don't forget to integrate both sides. Now, For the right hand side, to integrate 4x exponential negative 2x, we need to apply the by parts formula. Okay, integration by parts. So integration by parts is integrate u dv over dx equals to uv minus integrate v du over dx. So now our u is 4x. So the u is 4x. That means your du dx, okay, alright, du dx is 4. Then dv dx equals to exponential negative 2x. Then the v is to integrate exponential negative 2x. Then you will be getting e negative 2x over negative 2. Okay, after that, substitute into this formula. So for the left hand side should be no problem, just direct integrate. So I will get y to the power of negative 1 over negative 1, because minus 2 plus 1 is minus 1. So for the right hand side, by applying this by parts formula, it will be uv. Okay, so 4x times e negative 2x over negative 2 minus integrate v du. So e negative 2x over negative 2 times 4 dx. Right? So from here, left hand side, I will simplify. Because the y to negative degree 1, the y to degree of negative 1, then I will move it down. But the bottom part, you have negative 1. That means end up with negative 1 over y. So for the first term on the right hand side, the 4 and negative 2 can be simplified into negative 2x e negative 2x. Then now, again, for the second term, the 4 over negative 2, this is basically 2. But then negative is a plus. Okay, so I have to integrate plus. The 2 can be taken out. So you will get integration of e negative 2x dx. And again, now to integrate exponential 2x, exponential negative 2x, the answer already found in this step. Then I will just rewrite. It will be e negative 2x over negative 2, then plus c. So the 2 and negative 2 can be simplified. So I will get negative 2x, e negative 2x, right? The plus and minus 2, it will be plus 2 and negative half, it will be negative e negative 2x plus c. Now, we have solved, but we have to find the c. So when x equals to 0, y is 1. So when x equals to 0, y is 1. Now you replace, it will be negative 1 equals to, now x is 0, first term is 0, but second term is not 0 because e0 is 1. So I will get negative e0, first term is 0, then plus c. So here I will get negative 1 equals to negative 1 because e0 is 1, then plus c, hence the c is 0. Therefore, I rewrite negative 1 over y is negative 2x exponential negative 2x minus e negative 2x. Okay, now when you look at the question here, you are requested to get y as a subject because y in terms of x. So now to get the y as a subject, firstly I times the whole equation by negative 1. Then I will make it to positive for all the terms. Okay, and then now I notice that the exponential is in common. Then you can factorize the exponential to get 2x plus 1. Then the left hand side is 1 over y. So now to get y, simple, just move the y to the other side, then move this whole exponential, all these terms to the left hand side. So now I will get 1 over e negative 2x bracket 2x plus 1 equals to y. Okay, but then we can further simplify. 1 over e negative 2x is basically, you can move up. So it will be e 2x over 2x plus 1. Then this is going to be our y. Alright. So that's the solution of this question. Okay, now question number 8. By first expanding this, show the identity. So I will expand the cos square plus sine squared theta squared first. So again, now there is a square outside. Therefore, I'm going to use quadratic expansion. So formula a plus b squared is a squared plus 2ab plus b squared. So this is going to be cos square theta, you square it, plus 2, you multiply cos square theta with sine square theta, then you plus square of sine square theta. Okay, so this is going to be cos degree 4 theta plus 2 cos squared theta sine squared theta plus sine degree 4 theta. And now we need to show sine degree 4 theta. Now for your information, okay, cos squared theta plus sine squared theta is 1. That means this is going to be 1. So now I will write 1 squared equals to cos degree 4 theta plus sine degree 4 theta. Now, this part, when you refer to here, I have to introduce sine 2 theta. So now, my sine 2 theta, okay, sine 2a, okay, or sine 2 theta equals to 2 sine theta cos theta. So if I square it, right, if I square both sides, I'm getting sine squared 2 theta equals to, bring the square to the 2, becomes 4 sine squared theta cos squared theta. But then now here I get sine squared, I just get the cos squared theta sine squared theta first. So I can get this as a subject, which means the 4 will be moved to the other side. So 1 over 4 sine squared 2 theta is going to be my sine squared theta cos squared theta. Okay, so from here I will get plus 2. This cos squared theta sine squared theta will be replaced by 1 over 4 sine squared 2 theta. So from here, 1 equals to cos degree 4 theta plus sine, sorry, this is degree 4. Okay, because I copy from last term. Plus 2 times 1 over 4 is going to be 1 over 2 sine squared 2 theta. Alright? Then from here, I need to get this as a subject. So I have to move the half sine squared 2 theta to the other side. That means now I will get cos degree 4 theta plus sine degree 4 theta equivalent to this term moved to the other side. So it becomes minus. Okay, so with this, we have shown the identity. Okay, now part B. Hence means use the previous answer, solve this equation. So, and your theta is defined from 0 to 180 degrees. Then I will say cos degree 4 theta plus sine degree 4 theta equals to 5 over 9. So from previous, the summation of that two terms equals to 1 minus half sine squared 2 theta. I'm going to replace it by these two terms. So I will write 1 minus half sine squared 2 theta is 5 over 9. So move this to the right side and move 5 over 9 to the left side. I'll get half sine squared 2 theta is 1 minus 5 over 9, which is 4 over 9. Then now, my sine squared 2 theta times 2. So it will be 8 over 9. Then now my sine 2 theta is plus minus square root 8 over 9. Okay. Then now, you see, this is the interval for theta. And now we are solving for 2 theta. So I will write theta is defined from 0 to 180 degrees. Therefore, for 2 theta, you just times 2. It will be from 0 to 360 degrees. And now I can accept plus minus two values. So now I will draw the quadrant diagram. Since your sign is plus minus, that means you have to consider all 4 quadrants. Okay, so my 2 theta, the basic angle of square root 8 over 9 is going to be 70.53 degrees. So here will be the same, 70.53 degrees. Same goes to all this. Alright, so now based on this, my first angle is 70.53, my second angle is here, my third angle you have to plus, and the fourth angle you have to use 360 minus the basic angle. So I will get 70.53 degrees. Then when you use 180 minus that, okay, let's say I do step by step. Then I will get 70.53, and then the next one is 109.47 degrees. The third is 250.53 degrees, and then the last one is 289.47 degrees. All this belongs to theta, and now I need to get theta, and at the same time I divide. Now all these angles I divide by 2, and at the same time I round up to 1 decimal place. Then it will be 35.3 degrees, 54.7 degrees, 125.3 degrees, and lastly 144.7 degrees. So all these angles will be within the interval. Okay, because I already make sure that when it is 2 theta, my angle will be between 0 and 360 degrees. So this is a full solution of this question. Alright, so now question number 9. The equation of the curve is this. Show dy dx equals to this expression. So y e 2x minus y square ex equals to 2. So now there are two terms. I let this be u, this is v. Okay, I will apply the products rule. So d over dx uv equals to uv prime plus vu prime. But when you differentiate y with respect to x, we need to apply this formula. It will be d over dy fy times f times dy over dx. Because your f is a function of y, so when you differentiate, you must differentiate with respect to y. Okay, so at the same time I apply the products rule. So it means firstly I keep the y because my y is the u. Then when you differentiate exponential, let's say I write here u equals to y. So u prime is 1 dy over dx, because my prime here means dv over du over dx. Okay, then my v is e2x, my v prime is exponential, you just rewrite and then differentiate 2x, it will be 2. So when you use this formula, okay, I will get u v prime plus v u prime. So e2x times 1 dy dx, this is just dy dx. Then minus, okay, same for the next one. The next one is going to be u equals to y square. So u prime is, when you differentiate y squared with respect to y, is 2y. Then you times dy over dx. Then the other one will be the same. V is 2x. Then the v prime is 2e 2x. So now formula u v prime. So I will get y squared times 2e 2x plus vu prime. So e 2x times 2y dy over dx. Then for the right hand side, it is 2. That means you'll be getting 0. Okay, so now when I open the brackets, right? So I will get 2y e2x plus e2x dy over dx. Then times in the minus. So I will get both minus. So it will be negative 2y squared e2x minus 2y e2x dy over dx equals to 0. Now I need to get dy dx. Okay, so means that the first and last term will be grouped together, and then the other two terms will be moved to the other side. Okay, these two terms will be moved to right side. So now I will rewrite ex dy dx minus 2y ex dy dx equals to, when I move it to the right side, I need to get, see here, I need to get positive 2y ex. That means I will write down my 2y squared first. So I will get 2y squared e2x minus 2y e2x. Okay. Now, for the left hand side, I notice that the ex is in common. So factorize the ex. Then here you get the dy dx also in common. Okay, so dy dx. Then I will get 1 minus 2y. For the right hand side, the 2y e2x is in common. So 2y e2x in common. Then I will get y minus 1. So now I need to get this form. Okay. So then from here, let me check. Alright, so from here, I will move down. So dy over dx equals to 2y e2x bracket y minus 1 over ex bracket 1 minus 2y. So e2x over ex is basically e1x. So this can be simplified. This is e1x. Alright, so I will get equals to 2y e1x y minus 1 over 1 minus 2y. Now, we need to get the same form. Okay, so let me check. You need to get 2y ex to 2y ex minus y squared. Okay, so let me check what went wrong for the working. Oh, I found the mistakes. It's here. Here is e2x dy dx. Here is 2y e2x. So I miss out the 2, the degree 2. So e2x, here is 2x. Here should be 2x. Okay, after that, here, look at here. This is e1x, but here I wrote 2x. So mistake. Here is 1x, right? Here is e1x. So I didn't notice that. So this is e1x, which means for my second differentiation, I have to recheck. It will be uv. So it will be y squared e1x. So this is wrong. Okay, sorry about the mistake. So here is going to be y squared e1x. Then v du dx v u prime. So it will be just ex. Okay, mistake here. Alright, so when I solve, this one should not have. Okay, let me check. This one I have to redo. Right, let me redo. Sorry about that. So now here is going to be minus y squared ex. Bring in the minus 2y ex dy dx equals to 0. Okay, so now let me redo, then it will be easier to avoid the mistakes. Okay, so now let's redo again. So it means that now I combine these two terms. Okay, I rewrite. then I will get e2x dy dx minus 2y dy dx. So for the other two terms will be moved to the right side. Okay, the green one will be moved to right side. Then I will get y squared ex minus 2y e2x. Okay. Then now here, for the left hand side, the common is ex dy over dx. Then I will get another ex for the first term, and second term I'll get negative 2y. And for the for the right hand side, the common will be y, or basically I do not need to factorize the y, because when you refer to the question, I need to get y squared over here, right? So therefore, I will just keep it in this form and factorize just the exponential. So I get y squared minus 2y e1x. Because you have e2x, so when you factorize e1x, you still have e1x. So now the e1x, the ex can be cancelled off from both sides. Okay, then now my dy dx, it will be y squared minus 2y ex divided by ex minus 2y. But then when you check with when you compare with the answer, I should have minus y squared and minus ex, right? So now means that my position is different. Okay, the sign is different, so I have to factorize minus from both numerator and denominators. So when I factorize minus, now my second term, which is negative 2y ex, it becomes 2y ex. Then the first term y squared becomes minus y squared. And same goes to the denominator. When I factorize minus, my negative 2y becomes positive 2y, then my ex becomes negative ex. So now the negative can be cancelled off from both numerator and denominators. Therefore, at last I will be getting 2y ex minus y squared divided by 2y minus ex. Okay, so that is the solution of this question. Alright, so we have shown this correctly. Now, B, find the exact coordinates of the points on the curve where the tangent is parallel to y-axis. Let's say this is the x-axis, here is the y-axis. Normally, if let's say this is a graph, the tangent is parallel to x-axis means dy dx equals to 0. Okay, so now when your tangent is parallel to y-axis, that means it's here, which means the gradient of normal, okay, is negative 1 over dy dx. Then dy dx is going to be 0 because they are 90 degrees, right? So which means you should get 0 in the denominator. So that means from the dy dx just now, okay, that we have just proven 2y ex minus y squared over this. So now I have to let the denominator be 0. So when tangent is parallel to the y-axis, that means 2y minus ex is 0. Okay? But if let's say the tangent is parallel to x-axis, dy dx is 0 means that the numerator is 0. So from here, 2y minus ex is 0. That means y is half ex. I let this be first equation. Because now you need to find the exact coordinates of the points on the curve. Right? So which means now I need to refer to the curve equation. So go back to original question. The curve equation is this. Right? This will be my second equation. Then it will be intersecting. Right? So I will just copy the curve equation, which is y e to x minus y squared ex equals to 2. This is my second equation. Now I need to solve these two simultaneous equations because they will be intersecting. Right? which is here. Or I would say it is here. The normal line is basically this, not the orange color. Okay, so it should be this. So now substitute first into second. So I will replace my y by half ex. So half ex multiplied with e2x. Then minus the y is half ex. Then I square it, multiply with ex and equals to 2. So from here, I will get half. Now to simplify this, we need to use a to the power of m times a power n, which is a to the power of m plus n. Okay, because here e, when it is multiplication, that means we need to add the degrees. So it becomes e3x. Then the next one is going to be square of half, you get 1 over 4. This is e. Okay, now one more formula. A to the power of m, and then another power n. That means this is a to the power of mn. So I have to times this 2 to the x, which means you are getting e2x. So e2x times another ex means that e3x equals to 2. Okay, so half e3x minus 1 over 4 e3x, you are getting 1 over 4 e3x equals to 2. So times 4 to the whole equation, you will get e3x equals to 8. Right? So to get the e, we have to take ln both sides. So ln e3x is ln 8. So ln e3x is 3x because we have a formula ln e fx is fx. And then the ln 8, it can be ln 2 cubed. Alright, so now to get the x, the 3 move down, and at the same time we have another ln formula. Ln a to the power of b is b ln a. That means the 3 can be brought down. So I will write 3 ln 2. So 1 over 3 times 3 is 1. Therefore, my x is ln 2. Okay, now that is the requested answer because it's exact. But then now you need to find coordinates of the points, which means now we need to get y coordinate. So the y coordinates can be found by substituting the x value that we have found into first equation. Okay, into first equation. So from first, your y is half ex. So here I will write half ex. So this is going to be half e, the x is ln 2. For your information, e ln a is a. That means e ln 2 is going to be 2. Then at last my y is 1. So now, okay, you need to find the coordinates of the point. So I will just write the point with coordinates x is ln 2 and the y is 1. Okay, so we have solved this question. Now next question is number 10. With respect to the origin, the position vectors of A and B are given by these two. Find the vector equation for the line L through AB. So firstly, we need to find the direction vector of AB. So AB vector AB is vector OB minus vector OA. So this is going to be 0, 3, 1 minus 1, 2 minus 1. Therefore, right, 0 minus 1 is minus 1, 3 minus 2 is 1, 1 minus minus 1 is 2. That is the direction vector. So the line L, right, vector equation of the line L. So I will write R equals to OA. You can use OA or OB, up to you. So let me check. OB looks easier, right? So I will use OB. You may use OA, no problem. Then plus TAB. So it will be 0, 3, 1 plus T of negative 1, 1, 2. So that is our vector equation. Okay, now B. The point C lies on L is such that AC is 3AB. find the position vector of C. So since C lies on L, that means OC is same as the R. Okay. So now, basically, you need to find C. No need to use this. Okay, I can just direct solve this equation. So I will write AC equals to 3AB. So vector AC is vector OC minus vector OA. Then it will be 3AB. AB just now we have found. Alright. AB is negative 1, 2, 3. Negative 1, 2, 2. So here, negative 1, 2, sorry. The vector is negative 1, 1, 2. Okay. AB is negative 1, 1, 2. Here is 1, this is 2. Then now, OC is 3 times minus 1 is minus 3. 3 times 1 is 3. 3 times 2 is 6. Then you plus with OA. So now my OA from the question, 1, 2 minus 1. Then you will get minus 3 plus 2, minus 3 plus 1 is 2, negative 2. 3 plus 2 is 5. 6 plus minus 1 is 5. So this is your vector OC. Okay, now see, find the possible position vectors of the points P on L such that OP is square root 14. Since your points P lies on L, that means the position vector of P, right, which is the OP is same as the R. So now my R from the previous part, I have to rewrite now. It will be 0, 3, 1 plus T. Minus 1, 1, 2. This is the answer from the first part. So minus 1, 1, 2. Which means my OP is going to be the R. Okay, because the P lies on the line L. So now I will open the brackets and combine it to be one bracket. It will be minus T, then 3 plus 1T, followed by 1 plus 2T. Okay, then now OP means magnitude of vector. Okay, OP equals to magnitude of vector OP, which is square root 14. So now I will write square root 14 is magnitude of this vector. So it will be square root of square of negative t squared, means square of negative t, then plus square of t 3 plus t plus square of 1 plus 2t. Okay, so now we can square both sides to eliminate the square root. So cancel off. Therefore, 14 equals to, now do expansion, square of negative t is t squared. Square of 3 plus t, it will be 9 plus 6t plus t squared. And then square of 1 plus 2t is 1 plus 4t plus 4t squared. So now I will simplify all the terms. Look at here, 4t squared plus 1t squared plus 1t squared, total 6t squared. Then now, next is 6t plus 4t. That means it's 10t. Okay. Then lastly, 9 plus 1 is 10. Move this 14 to the other side because minus 14. So 10 minus 14 is minus 4. Okay. So now, this equation can be divided by 2. So here I will get 3t squared plus 5t minus 2 equals to 0. And this quadratic can be factorized into two linear factors. So 3t minus 1 for first factor and t plus 2 for second factor. So which means for the first bracket, I will get t equals to 1 over 3, or the second one, it will be t equals to negative 2. So now I get two t values. That's why when you look at the question here, possible position vectors, so you should get more than one value. Alright, so now once you have found the t value, just substitute back into this OP, because we need to find OP here. So now when t equals to 1 over 3, my OP is, just substitute back, minus t, so minus t, then after that 3 plus t, so 3 plus t, lastly 1 plus 2t. So here you will get, oh sorry, the t is positive t. Okay, so here you will get negative 1 over 3. So 3 plus 1 over 3 is 10 over 3. And then 1 plus 2 over 3 is 5 over 3. This is the first position vector. Then when t equals to negative 2, now my OP is, the first one is going to be negative t. Okay, so I will write negative of negative 2. Then 3 plus negative 2. According to the previous calculation, 1 plus 2 times negative 2. So this is going to be 2. 2 plus minus 2 is 1. 3 plus minus 2 is 1. 1 plus 2 times minus 2 is minus 3. So this will be my position vectors of points P. Okay. So now next question is question 11. The equation of the curve is y equals to square root tangent x, where the x defined from 0 to half pi. Express dy dx in terms of tangent x and verify that dy dx is 1 when x equals to 1 over 4 pi. Okay, so now I will write my tangent, my y as degree half of tangent x. Then now my dy dx, I bring down the half, rewrite the tangent x. The degree I minus 1. So half minus 1 is negative 2. When you differentiate tangent x, it's going to be second x tangent x. When you differentiate tangent x, it's going to be second square x. Alright, so now when I simplify, I will get second square x, because over, there is 1 half there, so over 2, and the power is negative half for the tangent. It becomes square root tangent x. And this is in the denominator. So this is my dy dx. Okay, done for the first part. In terms of tangent, right? I overlook it. Now to simplify the second square x, use the formula. 1 plus tangent square x is second square x. Therefore, I will change it to 1 plus tangent square x over 2 square root tangent x. So this is your dy dx, which is in terms of tangent x. Now, we have to verify. Verify means show dy dx equals to 1 when x equals to 1 over 4 pi. So now, when x equals to 1 over 4 pi, right, dy dx equals to 1 plus tangent square x is basically square of tangent pi over 4. Then over 2 square root tangent pi over 4. So tangent pi over 4 is 1. So 1 plus 1 squared divided by 2 times square root 1. So numerator is 2, denominator is 2. Therefore, it is 1. Alright, so this is verified. Okay, so now the next part is the value of dy dx is also 1 at another point on the curve where x equals to a, as shown in the diagram. This is a graph. Show that this function or this equation where t equals to tangent a. So now we know that dy dx is 1. Our dy dx is 1 plus tangent square x over 2 square root tangent x. and this is equal to 1. Now, when look at the question, it is 1 when x equals to a. So now I have to replace the x by a. Okay, so I do not write 1 first. So when x equals to a, dy dx is 1. So which means I will get 1 equals to 1 plus tangent squared a over 2 square root tangent a. Okay, and then I will change the tangent a to t. T is tangent a. That means I will get 1 equals to 1 plus t squared over 2 square root t. Okay, so the 2 square root t I will move up. Then the right hand side will be 1 plus t squared. But then when we look at the question here, there's no square root. Means that now we need to square both sides. Okay, so when I square both sides, left hand side is square of 2, I get 4. Square of square root t, it will be t. Right hand side I have to do the quadratic expansion. It will be 1 plus 2t squared plus t degree 4. Then from here, alright, I will get t degree 4. So move all the terms to the right side. So it will be t degree 4 plus 4t. Sorry, not plus 4t. Plus 2t squared. Okay, plus 2t squared. Then minus 4t plus 1 equals to 0. Now, we get t degree 4. But then you need to show t degree 3. T degree 3. Okay, so that's why it's mentioned here. It's also 1 as x equals to a. Then just now we know that when x equals to dy dx is 1, the x is pi over 4. Alright, so now from, let's say I let this be first equation. Alright, so from first part, from a, x equals to pi over 4. That means, alright, the x equals to a equals to pi over 4, which means our t is tangent pi over 4. That is 1, okay, from the previous part. Therefore, t minus 1 is a factor. Okay, of first equation. So now I need to find the other equation, which is this cubic equation here. So now I have to perform the polynomial division. Divisor is t minus 1 and the function is this. Okay, so I will rewrite. Now look at the function. After t degree 4 there's no t cube, so I will add on t cube with 0 coefficient. Okay, so I will add on 0t cube plus 2t squared minus 4t plus 1. I get it from here, from the first equation. Then now, to get t degree 4 from t, I need to multiply with t degree 3. That means you'll be getting t degree 4 minus t degree 3. Then when you minus 0t cube minus 1t cube, it will be 1t cube. Bring down the 2t squared. Now to get t cube from t, we need to multiply with plus t squared. This is t cube minus t squared. Then now again minus 2t squared minus t squared. It will be 3t squared. Bring down the minus 4t. So in order to get 3t squared from t, we need to times with plus 3t. Then you will be getting 3t squared and then minus 3t. Okay, and again minus 4t minus 3t means you are getting minus t. Then bring down the plus 1 and times by minus 1. then we will be getting minus t plus 1. Okay, so from here, alright, I will get t cubed plus t squared plus 3t minus 1. That is my quotient. And then I multiply with the divisor t minus 1, it will be 0 from the first equation. So now I will be getting t cubed plus t squared plus 3t minus 1 equals to 0. Okay, so with this, I have shown the equation when dy dx equals to 1. Now part C, use the iterative formula a with subscript n plus 1 equals to inverse tangent of this term to determine a correct to 2 decimal places, giving the results of each iteration to 4 decimal places. So now a n plus 1 is inverse tangent of 1 over 3 times 1 minus tangent squared an minus tangent cube an. Okay, and now your a, if you have no idea what is the a, okay, so let's see the a. So the a, the a obviously is between 0 and pi over 4, so you can use any points. I will start with 0. Okay, you can use 1 over 4 pi or the value in between the two values. So now I let a not be 0. Then I will get a1, that is inverse tangent 1 over 3 times 1 minus inverse tangent 0 is, tangent 0 is 1. Okay, this is tangent 0 is 0, right? That's why I purposely choose 0. Then here you will get inverse tangent 1. Alright, so here it will be 0.3218. So remember to calculate this using radians mode. Right. Okay, so tangent 0 is 0. So remember that. So now, to get 2 decimal places, make sure you get the same 2 decimal places, right, for the a. So now obviously they are not the same, then I need to continue. It will be inverse tangent 1 over 3 times 1 minus tangent 0.3218 squared, then minus tangent 0.3218 cubed. Then this is going to be 0.2767. Now when you check these two values, 2 decimal places, they are not the same, then we have to continue. So now a3 is inverse tangent 1 over 3 times 1 minus square of the tangent, then minus cube of the tangent. Then this is going to be 0.2904. Again, they are not the same. Okay, not the same. So now continue for the next calculation. So a4 is inverse tangent 1 over 3, 1 minus square of tangent of the previous value minus cube of the tangent for the previous a. Then you will be getting 0.2866. Okay, so from here, basically we need to calculate one more. Oh, sorry, this is 2866. Okay, so let me calculate. Okay, hang on please. So the answer is going to be 0.2876. Okay, so 0.2876. Now I'm getting the same value. Okay, so the final answer is going to be 0.29 because the next value is 5 and above, right? It's more than 5. So that's the solution of this question. Okay, so we have come to the end of the video. Thanks for watching. Please subscribe to my channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you. Bye.